I'm Alessandro Gallotta. I'm a software engineer at SysD and SysD Cloud, and we are monitoring microservices. So today I'm going to talk about what we know about microservices monitoring, troubleshooting, and containers that are strictly related to them. So I go straight to the point with a tweet I found some days ago that is the essence of all the talk. Basically, microservices are really cool, they have a lot of advantages, but they put a lot of extra fun, I'd say, into the troubleshooting area. We know that they are really good for scaling, deploying easily, and they are inherently good for distributed systems. But we have some problems with monitoring and metrics when we use them. It would be really nice to have some magic machine where we put all the metrics that we already know, like custom metrics, JMX, app checks, and all kind of metrics that we usually use in a normal host. And then we get out of this machine shining beautiful graphs and everything we need to troubleshoot and monitor. But this is not really what is happening usually. There's a lot of mess when you are dealing with microservices because you are adding a layer of complexity, because all the intercommunication that usually is missing when you have just one host and everything running on it is obviously multiplicated when you are dealing with microservices. So some of the points we are going to talk about in this talk are the challenges of containers, because we are focusing our activity on containers and they are a way to implement microservices, and it's getting pretty successful in the last years. And then we are going to check some limitation of monitoring, best practices of what tools like Kubernetes and Docker are using right now. And eventually I'm going to show you what's the approach that we are using at SysD, both from the local machine perspective and also from the distributed perspective. So first of all, we are going to forget everything we know about the traditional model of troubleshooting and monitoring. So accessing the physical machine, maybe SSH, and start checking what's going on, looking at the log, syslogs, or using the normal tools that you use for troubleshooting in the local machine. We cannot use it anymore because if in the traditional deployment we had some layers that were related to operations and they were sharing a lot of things in common like logs and tools for monitoring and troubleshooting. Now we have no more this advantage because we are gonna, especially with containers, we are gonna isolate our code. So if in the traditional deployment we had all the system services, software services that were installed and they were supposed to work all the time, and the application service were just relying on these services and working on top of them. The data flow was pretty easy to understand, and everything was really simpler, and every tier was really delimited in the resources that they were using and in the physical machines they were using. When containers, especially Docker, came into the game, they changed a lot the rules. So we switched from a paradigm where we had the physical servers or virtual machines that were mostly monolithic with a little bit of orchestration. We then arrived to a paradigm with containers where we have a lot of orchestration. Even if you have one single machine with containers, you have to deal with all the troubles that you have with networkings and communication services. This is very good because it forces you to code and deploy your application to easily scale regardless of how many real machines you have underneath. But it obviously adds complexity. On the deployment point of view, now it's for some reason easier because you have a container with all the dependencies that you need for your application. So in this case, all the system services like MySQL and Nginx and Java, they are split each is container, so they are not interfering one with each other, and the operations, the normal installation and setup of the machine doesn't have to care about the version, the configuration of these tools. So it's really taking off a lot of head cases from the DevOps. The problem is that we are taking this advantage adding complexity. The first type of complexity we are adding is numerical and heterogeneity of the containers and on the entities that we are running in our physical machines. These computing nodes could be virtual machines and normal hosts, and we can see that the tiers of the application that first were pretty easy to isolate and understand now are mixed all in the different computing nodes. And if you realize their relationship, everything is getting even more complicated. In this way, it's really hard for you to distinguish what you need to know about, for example, the cache in the standard way. Like if you SSH in a machine, you have a mess, you have a lot of noise of all the other metrics of other services. So we really would like to have back the original application workflow, because from an application point of view, this is what your application sees, is still the neat and clean data and application workflow that is passing one tier to the other. The problem is that really the tiers are, from a human point of view, are really messed up in a mesh. And when the application is working and everything is beautiful, you can see that you can trust the tools that you are using, that the data flow and the application flow and everything is working like expected. But when you have to troubleshoot, what you really need is to get into the mesh and in the mess and check what is not working and try to detect everything at a minimum level of details. So there are new challenges that come up with microservices and containers. First of all is how do we get the metrics that we want from this mess? We have to isolate them and to take all of the data that we want with a minimal overhead. Another point is how do we present the metrics to the final client, to the one that is going to use them? Because if we just throw them all the numbers, all the metrics that we collect from all the containers, it's almost impossible to understand anything about what's going on. And then we have to make analysis and troubleshooting on this, and then I will make an extra bullet point on how to try to divide the job in teams when you're working on microservices and isolated part of code. So, going with the first point, the metric collection is a problem because containers are a black box, they are not transparent, they are willingly isolated, they must be self-contained, they must be like entities by their own. And they have a lot of pros, they are simple, they are really lightweight. A few megabytes of programs are running usually on a container, so you can create containers and destroy containers in a few milliseconds, and you can have thousands of them. You can escalate really, really well, much faster than virtual machines. On the other side, we have a problem with metrics collection for containers, because since they are isolated entities, we should instrument every single container. But if we instrument them one by one, we are going to add a lot of overhead, and we are slowing it down a lot, and we are breaking the paradigm of containers. They must be focused on just one task, and they must be really, really lightweight. So, for example, I had in the previous talk of another monitoring tool that they were using extractor for every program, every service that you were having installed and you want to monitor. This means that you are adding overhead for every program that you are using. Another approach that is a little bit better is the one of Kubernetes. So you have an instrumenting pod and you are fetching the metrics from cAdvisor and from the API of Docker. But these are still limited to the Docker and Kubernetes application. The solution that we've developed at Sysdig is to use a kernel module that you install. It's an open source module, so you can verify the code, and it's pretty trustworthy and used across the world. And you can fetch all the type of data that are passing through the kernel. So basically everything that is going on in your machine, also other containers. So we are monitoring other containers being in an external container. all the dependencies and the ease of scale and performances of a container is now an advantage for us, because you just have to deploy a container with this monitoring tool, and all the node computing machine will be instrumented. For example, in Kubernetes, you can simply add in the API that for every machine you want to add a SysD container, and you will have all your infrastructure instrumented with the least overhead possible. These are exactly the two main advantages that we are having using kernel instrumentation. So one per host, the least overhead, and full visibility of all the system calls. So we can get all the metrics from the native host and all the other containers. This is also very useful for security purposes that we are developing. So once we get all these metrics, we obviously have a lot of tiers mixed together in the host node, in the computing node, and we want to make them clearer and easier to understand from a troubleshooting point of view. So to do this, we would like to aggregate this information in a fashion that the user can customize, and maybe using metadata that depending on the infrastructure depending on the infrastructure, and aggregate and make calculation on these metrics depending on how you want to see your infrastructure, not how it physically is. So you really want to get back to the natural visualization of the tiers regardless of the physical machines that you have underneath. And this is exactly what a lot of orchestration platforms are trying to do already. For example, Swarm or Kubernetes or Mesos, they want to abstract everything about deployment of the infrastructure in a way that the developer or the DevOps doesn't have to focus on which containers are going where, and just ask what he wants, and the tool will do everything. I will do a quick demo now to make it clearer. Unluckily, the window is really small. I hope it's clearer to see. So this is our tool, and this visualization is a graph containing the physical machines that are in an infrastructure that deployed with the Kubernetes containers. You can see that inside, if I zoom in, I can expand the nodes, and I have a mess of containers, exactly the same mess that we were having before. We have containers, other programs, and they are talking with each other. They have networks that is established between containers, all this mess information. And if we want to analyze, for example, the network activity, that is what you are seeing in this blue box, it's really, really hard to understand which tier you are dealing with. For example, you want to see if your backend is under stress, or if the frontend is losing some requests. It's really hard to debug and analyze with this kind of view. So we have other forms of view. For example, this one is using a very same infrastructure, but is visualized using metadata from Kubernetes. Here we can see that we have two bigger namespaces. That is the development namespace of Kubernetes and the production. And if you zoom in, you can see here that you now have the tiers. This is a lab infrastructure that is actually running. We're fetching data and sending them to the cloud with our tool. And we can see that we have the clients, we have our application, in this case the job application, we have our backend services, and we have our database, like a few nodes of Cassandra and Mongo, and they are all run in containers. And they are not necessarily run in the same host. We saw before that there was a lot of intercommunication between different machines, but in this way we are just visualizing the containers grouped with the metadata that we fetch from Kubernetes. So we don't care if one node in Cassandra is in a host and another one is another. If they are working on the same service, on the same namespace, and all these criteria obviously can be chosen by the user, we can visualize them in the same block, I'd say. So you can obviously make all kind of analysis easier with it in this way. Another form of view is this one. Is again the very same information that we are extracting from the kernel, but in this case as a table, and you can see the standard metrics such as CPU and memory and other things, and you can also have a bunch of other custom metrics with different visualization. For example, the classic time series. And you can segment this with all the criteria that we fetch from the metadata, not only the container labels, but also some tags like the AWS tags or the process name, for example, if you want to get a lower granularity. In this case, since I selected a host with mainly just Tomcat container, it will just show what's inside your selection. And this obviously can be changed with any grouping criteria that you want. You can also customize it. For example, I have another infrastructure, test infrastructure, that is using Mesos and Marathon. And you can see in the same way that we have this messy network of containers from a natural visualization. But if we go to our representation, everything starts making sense. At a glance, you can understand what my infrastructure is using, how it's composed, how these links are dynamically created with the connections. So you know if your MySQL is connected to the WordPress, or if the link is missing, then it means there is something that is going wrong. So it's really easy to understand your infrastructure in this way. Going back to the slides, now we understood that we can get the metrics in a really efficient way, just with an overhead minimal per host instead of per container. And then we can segment and aggregate the data at a level that is really efficient to customize the visualization and see what kind of data we want to show. Another step to get deeper in the troubleshooting of container is, for example, this issue that was found on GitHub, on Kubernetes repository. You can see that there is a huge lack of monitoring tools. Here is trying to replicate a delay, a suspicious bug, and the only thing that is possible to do to replicate this bug is simply to try again to start a container, adding a bash line to try to replicate the issue because they have an idea. But obviously this is not possible for a lot of bugs. Maybe some bugs cannot be replicated, or you have no clue why they are happening. And this troubleshooting way, it's really, really hard. It would be really nice to have tools in your containers that allow you to use the standard tool set like TCP dump or Wireshark for network, and VMstats, HTOP, all these tools that if you're using containers, that are not included because they will have too much weight in a container image. So you also would like to analyze logs and get a lot of information and introspection on your container. Using the same technology, I can show you it's pretty easy to do this. So I'll zoom out a little bit. So I'm using sysdig now from command line. This is a local installation, and you can see that I'm using a capture file. If you have ever used TCP dump or Wireshark, you are pretty familiar with the syntax. So what is sysdig doing from the command line is what TCP dump is doing for the network. So instead of intercepting the events that are getting into and from the network, we are intercepting the system calls that are getting into and out your kernel. So we basically see all activities, also the network activity of your computer, and you can add script that we call sizzle. For example, this one is checking the biggest files by containers, and we can see that in this capture that I've done before, I have a few containers that are running a WordPress and a MySQL database. So it's to write captures of sysdig is as simple as using the -u argument and then the name of the capture. So you can simply launch it and it will start recording. And then with the -r, you can read again and check all the events and the data you have collected. So in the previous case, for example, in the issue that I showed you, you just need to record once what happened, and then you can simply read again the file that you have recorded, and you will get all the information that were stored during your capture. And this is for every system call. For example, some month ago, there was some big customers of us that was having an issue because sometime it was crashed, our server was crashing, and there was not even time to write the kernel log or system log, so they had no idea how to do that. The only thing that they were able to do was to keep our tool running and capture the events. And with this capture file, they were able, in weeks of working on that, to extrapolate what was the cause of the outage. So this is very useful when you have to debug something. You just maybe restart your production environment, and you can go on for weeks working on the captures on your free time, looking for the issues that caused the outage. We have another interface from the command line that is called sysdig. It's a course UI, and you can see here that it's pretty much desktop, but it's reading from a capture file. And in this output, you can see the familiar programs and in the containers and everything that was captured there. But other than that, we have a lot of different views that are analyzing Kubernetes metadata, Marathon metadatas, container metadatas, for example. And with this simple interface, you can drill down and navigate through what you are selecting. For example, if I get press enter here, I will add to the filter the container, and now I'm looking just at the processes of the container. I can go back to another view and maybe see the connections that this container is doing. And in this case, there are connections going to the MySQL. And so on, you can really analyze all the system calls with this easy-to-use interface that you can use also with a terminal because it's just a curious UI. And also we have other modalities that we call dig, that is the system calls, or it displays the system calls that are shown from your selection. And another one is the echo, that is showing the output. Obviously, connection will have no output probably. If we go to this project set, for example, we will see that these are all the bytes that are written by the process during the capture. And if we use another visualization, we can see maybe some nice data going up and down with this, within this process and this container. As you saw, if you read here on the top, I'm looking at this container ID, so I'm already navigating through the containers without having to specify what's the name or looking in Docker to see the ID. It's really natural and easy to go through your containers and find out maybe what programs are working, what are the errors, for example, that are more numerous in these containers. And you can basically do your troubleshooting in a really interactive and easy way. I will not say fun, but someone does, I don't know. It depends. So, going back to the presentation, I think there is some more time. The last bit I want to add is that we saw that a lot of companies, especially big ones, have a lot of arguments between and contrast between teams and what privilege should teams have and what they should be able to do and see. So basically we are dealing with an ACL problem, so we want to show some data to a team, for example. We don't want them to see other stuff because they are maybe different customer or they are sensitive data, because extrapolating a lot of data means that you can really know a lot about what's going on in that machine, and maybe those containers are not even yours. So this could cause a lot of issue. To overcome this, going back here, we developed a feature that we call teams. So in this, if the connection will work, we will eventually see. So what they basically do is to add a filtering like the one that I showed you before in the command line to everything that you see in the interface. So for example, if I set a namespace equals to dev, in the filtering, I will just see everything that is under the dev namespace. So if I want to hire new developers, I don't want to give him access to production. I don't want him to see our metrics in production or for any reason. We just assign them to the team, so he will be able just to see those data. This is also useful because maybe you are working in just a subset of the infrastructure if it's really big, and you don't want to visualize all the other material, all the other metrics of everything that is not competent to your work. So I think that this will load forever because probably I'm not even connected to, Wi-Fi is working. Let me update the page. Okay, it finally loaded. So as you can see now, even if the screen is really small, I can see now just the development namespace. And I will show you the topology, but we have a bunch of other metrics. This is maybe the easier visualization to let you see what you are able to get. So now we have just one block. We don't have any more the production namespace in the other namespace. And you can just see this data. You can put alerts on this data. Just to let you understand better why this is crucial, we can have, for example, a lot of sensitive data about the SQL queries, and the visualization is not the best since the screen is really small. But you can see that we can also sort and show you what are the slowest SQL queries or the one that are queried the most, so you can optimize your application. All these also can contain pretty sensitive information, so it's really useful to hide from people that should not be allowed to see them. So after this, I will just sum up the features that I showed you. The open source tool from the command line is 100% open source. You can contribute to it. It's really widely used, especially in the States. And the other one with the web interface is our software as a service and on-premise solution. And we have a bunch of customers, and we are storing the data, and we are doing all the job that Prometheus were mentioning in their talk. So we are storing for long-term data, we are visualizing with Graph, we are allowing to set alerts and collect events and all the other tools that are useful for troubleshooting in the cloud. So I think the time is pretty much it. So if you have any question, I still have maybe 5 minutes.